Levers are a type of simple machine. They can be used to amplify force or distance. A lever is made up of three components. A force arm, which refers to the distance between the point at which the force is applied and the fulcrum. The fulcrum itself, or axis, and a resistance arm, or the distance between the point where resistance is applied and the fulcrum. Levers can be classified as either first, second, or third class. First class levers can be used to amplify speed and strength. The fulcrum is between the points of force and the resistance. As the axis point is moved closer to the point where force is applied, the faster the item can travel. If it is moved away from the point of force, this enables a greater level of force to be applied. A second-class lever is characterised by having the axis at one end of the lever and the force at the opposite end. The resistance is located between them. Second-class levers have long force arms, allowing them to generate great strength. A wheelbarrow is a good example of this type of lever. The third-class lever is different again. Like second-class levers, the axis is at one end of the lever, but now the resistance sits at the opposite end and the force is between them. Third-class levers have long resistance arms, which can generate great speed. Most levers within the body are third-class levers. The human arm is a good example. Consider a swimmer doing freestyle or backstroke. The arms are acting as third-class levers. The shoulder is the fulcrum, with the force coming from muscles in and attached to the upper arm. And the resistance is the movement of the hands against the water. Because the hands move a greater distance than the upper arm, where the force is generated, but in the same period of time, the speed of the hand movement is considerably greater than that of the upper arm. This is just one example of a third-class lever inside the human body. But there are also a range of levers external to the human body used in sport. An example is a tennis racket. It acts as a third-class lever. The shoulder of the athlete is the fulcrum. The upper arm and forearm muscles act as the force, and the ball being struck by the face of the racket is the resistance. The laws of physics would suggest that the longer the handle of the racket, that is, the longer the distance between the force and the resistance, the quicker the serve. Although this is true, in reality, the biomechanist must also consider how much control the player has over the ball, and therefore the desired accuracy. Over recent times, principles of biomechanics applied to modern technology has led to the development of an optimum range of lengths of the lever from hand to racket. The athlete will have more control with a shorter lever and more speed with a longer one.